In this video, we're going to talk more about continuity and applying the continuity test, as well as determining where functions are continuous. So if you were asked to prove or show that a function is continuous, you would need to show three things. You would need to show that the function value f of c exists at that point where you're attempting to prove continuity. So you need to show that the output value exists, which means I can plug c in and get a value out. We also need to show that the limit as x approaches c exists. So there's a function output and a limit at that c value. And then part 3 just says that that output value, f of c, and the limit as x approaches c, those need to be equal. Okay? So the function output value exists. The limit exists. And 1 is equal to 2. All right, that's how we prove continuity. So let's look at an example. So for this example, we're going to prove that the function f of x equals x squared is continuous at the value x equals 3. So we do three things. The first thing we do is we evaluate the function at x equals 3. F of 3 is 3 squared, or 9. The second thing that we do is we show that the limit as x approaches 3 of that function is equal to that same number. And so in this case, this is the same as finding the limit as x approaches 3 of x squared. And when we are finding the limit of a polynomial function, we just can evaluate the function at that c value. So that would equal 3 squared, which is also 9. All right? And so since 1 is equal to 2, we can say, therefore, f of x is continuous at x equals 3. And that is how you show something is continuous. Now, we don't have to do that very often, prove continuity, but understanding continuity is essential to later definitions in calculus. When we start talking about derivatives and integrals, we say, well, as long as it's a continuous function, then we can use these rules. Okay, so we need to understand what continuity is. And of course, if we think about this graph, this is the graph of a parabola, and we know it's a parabola opening up, origin or vertex at the origin 0, 0. There's a point on the graph 3, 9. There are no breaks in the graph of this parabola, right? So we know it is continuous. Where is the function continuous? All right, so we could go a little further here, and I could say, where is f of x continuous? And essentially, all this is asking us is to say, what is the domain? And we know since f of x is a polynomial, x squared, it's a parabola, we would say it's continuous from negative infinity to positive infinity. X is an element of that set of all real numbers. All right, so continuity, when we ask where is a function continuous, generally we're just responding with the answer of the domain. So let's look at stating where a few more functions may or may not be continuous. So for this example, we're going to say at what values of x is this function continuous? And here we're given the function f of x equals 1 over x minus 2 minus 3x. And really, we know it's going to be continuous everywhere except for where this denominator can become 0. And we can easily see that x is not allowed to equal positive 2. So the function is continuous as long as x is any number except positive 2, because positive 2 would create a 0 in the denominator. So we would say on the interval from negative infinity to 2, union 2 to positive infinity. Let's look at another example. So for our second example, we're going to examine g of x equals x plus 1 divided by the quantity x squared minus 4x plus 3. So again, we have a rational function here, and we know that whatever values make that denominator 0, those are the values we would need to omit. So when we're dealing with rational functions, we like to make sure we factor them first. This denominator factors nicely x minus 3 and x minus 1. So here we can see there are two values x is not allowed to equal, positive 3 and positive 1. So the interval over which this function is continuous would be anywhere where x is from negative infinity to 1, union the interval 1 to 3, union the interval from 3 to positive infinity. And just a refresher, when I write x element, that element symbol means that x is a member or an element of the set. X belongs in the set. Okay, let's do one more. This one will have trig in it. So for this example, if we're trying to determine where the function is continuous, we're going to need to consider that we have an even root and a trig function. Okay, so even root, one thing we know is that the values under an even root need to be greater than or equal to 0. So this lets me know that x has to be greater than or equal to 0 because x is my expression under the radical. All right, so we also in this situation have a denominator. And remember, the denominator is not allowed to equal 0. So we may also need to say, okay, well, where does sine x equal 0? Because if sine is equal to 0, if sine of that argument is equal to 0, we're going to have an undefined value because you can't divide by 0, right? So you can say equal to or not equal to. We're just trying to solve and say, well, where does this function equal 0? Because whatever those values are, that's what we will omit. And if you think about the graph of sine, that's going to occur when x is at any pi value plus k pi. Okay, you could also say that as x is 0 plus k pi. If you think about your sine graph, you've got zeros at 0, at pi, at 2 pi, and that would continue along. We would have 3 pi, 4 pi. So at 0 plus any pi k multiple. And in this case, we are just saying that k is an integer. I use the z symbol here to represent integers. So k belongs in the set of integers. So what we know is that x has to be a positive number greater than or equal to 0 plus any pi k integer. And in this situation, integers can be positive and negative. So we need only the positive values. So here I would say x is in the set from 0 to positive infinity, comma, x cannot equal 0 plus pi k, comma, k is an integer greater than 0. So I'll say k is an integer and k is greater than or equal to 0. So we have to have a positive integer. And so positive integers, we could write that and say that k is a natural number. So I'll use that n symbol to mean natural numbers. And I do notice that I wrote a bracket here. It's not allowed to equal 0 because 0, sign of 0 is 0, and that would give us 0 in the denominator. So I do need to make sure that's an open interval on both sides. So I hope that helps you a little bit with, understanding how to state the intervals over where a function is continuous. Essentially, all you're doing is finding the domain.